Hello, my name is David Hatch of Process Safety Integrity, and thank you for your interest in my poster, Hazard Analysis of Battery Energy Storage Systems. Quite simply, this is a visual technique to better evaluate, understand, and manage the potential process safety or loss of containment issues associated with current and developing energy storage systems. Whether it's lithium-ion or other fluid systems, we appreciate that electrolytes can be hazardous. They may be corrosive or toxic in their normal liquid state, but when the cells are distressed, they can release toxic or flammable vapors, which in the worst case could ignite, causing a fire or explosion. But these are not unknown issues, and the energy industry is well aware of these and are working to address them, but it becomes even more critical when you have battery storage systems next to vulnerable assets or communities. So, as I said before, the hazards or the causes are well understood. Typically for lithium-ion, it's excessive charging, voltage surges, short circuits, or mechanical impact. So it's not an unfamiliar landscape to us. But what we have to do is make sure that we properly evaluate and communicate those hazards and their controls. We have, depending on your jurisdiction, we have some codes or regulations which we may have to comply with. So, for example, in the US NFPA 1 fire code requires a hazard mitigation analysis, and it suggests a number of scenarios or failure modes that have to be properly evaluated and managed. One way to do this is to use bow ties. So the basic concept of the bow tie is to visually represent scenarios. At the heart, we have hazards with the potential to cause harm. We lose control or containment with the top event, which could lead to significant consequences. The top event or loss of control is caused by various threats, and we prevent the threats leading to loss of control with prevention barriers, and we reduce the impact of the consequences with mitigation barriers. Bow ties offer a more powerful representation. Threats and consequences are more obvious, and we have an immediate sense of our defense in depth. What type of barriers do we have? What are their relationships, for example? So here we have an example sanitized failure mode and effect analysis. We have multiple threats leading to the loss or control or containment of hazardous materials and energy, multiple consequences here, using the threat likelihood, the barrier, prevention barrier, effectiveness, mitigation barrier effectiveness, and the consequence severity. We can get a sense of the risk and the risk reduction requirements. So from our experience, we've applied bow tie analysis to a number of battery storage projects, and the duty holders have seen significant benefits in the understanding of not just the technical stakeholders, but also the less technical, the maintenance operations personnel. And fundamentally, if you don't understand the hazards, then you're not able to manage them. So having a clearer understanding allows you to make better informed decisions to put in additional prevention or mitigation measures. Thank you very much for your attention and your interest, and I look forward to any questions that you may have. Thank you.